through the WhatsApp group or through Zoom chat? What do you prefer? How do you prefer? Tell me on the Zoom chat. Should I open the group or shall we continue through the Zoom chat? All right, so majority is on Zoom, so we will go on Zoom. All right, so you all are from 2022 batch, which means you guys have like around 40, maybe if you have the exam on next month 15th, that means around 45 days roughly. So is it enough? Yes, definitely 45 days is enough to make a change. So don't care what others say. There are maybe people who say like time is not enough. This is like a lot of things. Don't care at all. Like 45 days is more than enough. Only thing is you need to do some hard work. You need to, if you work, I mean, you need to do everything. No, I mean, it's not confirmed yet. Not 15th is not confirmed, but I just said roughly 45 days. So if you work hard, yes. So if you work hard, you can do anything. So only thing I want you is to work hard. Make a plan. You have 9 subjects. O-level is an easy exam. You have 9 subjects. So make a plan, have a timetable, work efficiently, not the time, the quantity, how much you learn for one day, you study for one day. It's not enough, but it's not at all what I'm telling. What is important is the efficiency. How efficient you are. It's normal. Even if you work 2 hours a day, that's more than enough. But the only thing is you need to do that 2 hours correctly, more efficiently. It should be fruitful. Even if you study 24 hours, if you just sit on the table, use the phone, use WhatsApp, go to Facebook, just sit on the table for 24 hours, there won't be any use. But if you fruitfully use the 2 hours, yes, that is more than enough. So trust me, O-level is an easy exam. It is, I mean, when you compare with your A-levels, it's nothing. It's like the alphabet. So O-level is really easy exam. A-levels is difficult. Yes, I accept that, but O-level is nothing. Only thing is you have 9 subjects. You have to manage properly. Right. Coming to maths, many students think maths is difficult. Many, I mean, not, there are people who feel like maths is easy, but majority in Sri Lanka especially thinks maths is difficult. But maths should be the easiest subject you have. Why? Because it is something you don't have to study. Because if you take history, if you take science, you need to memorize. If you don't know, you don't know. If you don't know who built Runway Masaya, you don't know. But maths is nothing like that. You can, it comes within you. So everyone can, I mean, it is a logic. So in mathematics, you are always allowed to ask why. If you have this habit of asking why, then definitely maths will be an easy subject for you. Okay, so I hope I don't have to tell the structure of the paper. By now, you should already know because next month you are facing the exam. So you have 2 papers, you know that, paper 1, paper 2. Then in paper 1, you have part A, part B, part A, and part B. So, you know, here you get 2 hours for this one. You get 2 hours. It's a 2-hour paper. So for these 2 hours, you have to do 25 simple questions, and another 5 structured essay questions. So my advice is, these are like really simple questions, right? So you can do them in 2 minutes, but 2 minutes, so 2 into 25, it is 50 minutes. So try to finish this paper 40 to 45 minutes maximum, right? So in 40 to 45 minutes, you should be done with the 25 questions. There may be questions that you don't know, right? Maybe the 15th question is a little bit, I mean, maybe you don't know, maybe you know, you forgot. Do not stay there. Just leave it, just mark it, just draw a line. Like you have 15th question, blah, 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 blah. So you just mark a line here, you move ahead. do not stay there. Do not stay at one question more than 2 minutes. If you don't know, just leave it. No problem. Right? So, I mean, in the exam, final exam. So, that is about the first 25 questions. Right? So, after that, let's say with checking and everything, you have another lot of plenty of time, right? So, here, 5 questions you have, maybe around 12 minutes per question. So, if you take 10 minutes per question, you have 5 questions, 50 minutes. So here, let's say 50 minutes, here 50 minutes, you have extra 20 minutes. Why extra 20 minutes? That is to check. Here also, again, same thing, right? So here also, maybe first question, you did the first part, you did the second part, you did the third part, but the fourth part, you know, but you cannot remember. Yeah, come in. Hello. Good afternoon. Yeah, sit. All right, so I was telling, maybe the fourth question is a little bit hard. Maybe, I mean, you don't know the fourth question. So what you should do? Should you stay here? No, never. Do not do that. Just skip this question and move to the next question. So 10 minutes, 12 minutes maximum for one question in structured essay, right? So that's, then you get 50 minutes. So that 20 minutes, I said 50 for first part 1, 50 for second part. Then you have another 20 minutes in extra. So that 20 minutes is for checking, and just, I told you to leave some questions, right? So when you leave those questions, you can do those questions using the rest that remaining time. Okay. Then in the second paper, how many questions do you have? How many questions do you have in the second paper? Yeah, 6 questions are there in part A and 6 questions are there in part B. So here again, out of 6, you have to do 5 questions. Here out of 6, you have to do 5 questions. So here for these 5 questions, you have 3 hours. 3 hours means 180 minutes. So for one question, how many minutes? You have 18 minutes for one question. But do not take 18 minutes for one question. How many minutes you should take? 15 minutes, more than enough. So for one question, 15 minutes. So you have how many questions? 10 questions. In 150 minutes, you are done. That is 1.5 hours. In 1.5 hours, you will be done with your paper. So here also again, suppose first question you did in 15 minutes. Second question you did in 10 minutes. So for the third question, can you give 20 minutes? Never do that. Finish it in 15 minutes. Okay. And if you do not know the fourth question, I mean the fourth question, you know half. First part, second part, third part, you know, or third part and fourth part, you don't know. What you should do? Just leave them. Just leave them and go to the next question. After your 15 minutes is finished, just leave them. Because I'm telling this because if you stay in one question, so generally, like let's say the fourth question, you have first question, second question, third question, and fourth question, or maybe fifth question. So the marks will be given like 2 marks, 3 marks, 3 marks, and 3. So maybe 6, 7, 8, and 2 marks, right? So 10 marks will be given like this. So if you just stay here for here, I mean at one place, because you just cannot understand, you're wasting your time and you're just for 2 marks. But if you move ahead and in the next question also, if you do 2 questions in that time, you would have gained 5 more marks. So 15 minutes maximum per question. And again, so from one question, you are saving 3 minutes, right? Then 3 into 10, how many minutes you will have at the end? 30 minutes. Why you are having that 30 minutes? To do the parts that you left, right? So that is how you should plan. So you should have this timing. I mean, definitely you should have a watch with you during the exam, and this timing should be there. If you do not follow this, definitely the time will not be enough. Even if you are at the level of getting an A pass, B pass, still the time will be not enough if you do not manage. So your A can go to C because of inefficient time managing. All right. So that is a brief discussion about our paper. Can we do extra questions? Yeah, you can do extra questions. But this is something that changes every year. So generally, if you do extra questions, what they will do is they will cut off the lowest marks. Whatever I mean, you have to, there are 6 questions, you need to do 5. But if you do all the 6, the question with the lowest mark, they will cancel off. But this is something that changes every year. So this thing we have to get confirmed by someone who goes for marking, I mean, paper marking. But generally, most of the time, what they do is they cancel off the question with the lowest marks. So that is good thing. If you have extra time, you can do all the questions. But get it confirmed, especially your school teachers are the best people to ask this question. Because me, myself, I'm not going for paper marking. So, all right. So today we are going to, this revision. Let's talk about the revision also. So here the revision we are doing, I mean, in our revision series, we will cover our main lessons, like we have triangles, circles, probability. So likewise, we will what you call bunch up the important sections and cover section by section. So today we are going to discuss circles. So there are around, I think, if you collect all grade 10 and grade 11, there are around 5 to 6 lessons related to circles. All right. And then finally, towards the end of our revision series, we will go through papers, model papers, and important past paper questions also. All right. Can you tell me, what is a circle? Simple question. What is a circle? Online students also, you can tell me your answers. What is a circle? Yeah, what is a circle? I mean, suppose I'm an alien. I don't know what is a circle. I mean, I don't know how will you explain me? What is a circle? Something like okay. A figure, a curved surface. Again, I'm an alien. I don't know what is curved surface. Circle made of circumference and radius. Okay, and now the hard words. Circle is with 360 degrees. Okay, line drawn from the center. Round shape. All right. How about you guys? What is a circle? Round plane figure whose boundary. All right. So every circle has something at the, what is this? What is this? Center. If you keep a lot of dots equal distance, yeah, come. Yeah, there's one student called the law of a point moving at constant distance. Yes, that is the correct answer by Prishantini. Yeah, okay. Tell me, what is a circle? What is a circle? Round shape. What is round? I'm sorry? What is a circle? All right. So we have a fixed point. So we are keeping lots of dots equal distance from this point. That means we have this point. We are moving this point equal distance. This distance is not going to change. So we are going to move this circle equal distance from that fixed point. That is called a circle. All right. So this is, I mean, a circle is a really, I mean, this is a really important shape. That is why you have a lot of what you call theorems. In your syllabus, you have lot of important theorems related to circles, right? So this is a very special shape. If you take square, rectangle, there's no much things, but this circle is a very important shape you have in your syllabus. Okay, so tell me, area and perimeter. You already know, right? What is the area of a circle? Squared. Pi r squared and the what do you call perimeter? 2 pi r squared. This is squared. 2 pi r. All right. So first of all, let's talk about the parts of a circle. What is this? It's a center, yes. And what is this? The circumference. Okay. Now tell me the distance from center to the circle, we call it the radius of the circle. Then the other part, what is this? Diameter. When you talk about the diameter, there is another important, yes, there is an important part. When you just mark, I mean, diameter is something you draw between 2 points of a circle and it is passing through the center, right? What if you draw a line like this? What is it called? It's a chord. And then the chord will divide the circle into 2 parts. What is it? We call it minor segment. How about others? Minor. We call it segment. We call it segment. So there are 2 segments. The larger one is the major segment. The smaller one is the minor segment. All right. And then what if you draw 2 what if you do 2 radii, like a piece of cake? What is this? Yes, it's a sector. So there are, how about the other part? There are 2 types of sectors. This is the minor sector and the larger part is the major sector. All right, is that all? Anything else? Anything else? Arc. Yeah. So this one we call the, I mean, here when you draw the chord, it will divide the circle into 2 parts. What is this? Minor arc and the larger one we call the major arc. So this line, the curved surface, we call it arc. Anything else? Anything else? I don't know. That's all. That's all. Radius we marked. Chord we marked. How about tangent? What is a tangent? Tangent is something that touches the circle only at one point. We call it tangent. Tangent, right? That's all, right? Okay, so shall we just mark it as the beginning? You have writing books, right? Something to write? It will be 5 hikmah. What about semicircles? Yeah. Then again, semicircles means half of the circle. So the diameter, we'll divide it into two semicircles. One student is asking, if circle theorem comes to exam, is it better to choose that or taking other theorem? First of all, it is not an if. Definitely, circles will be there in your exam. So you have two proof questions. One is from triangles, the other one is from circles. So if you are comfortable with circle questions, you should. I mean, it's something easy. Circle theorems are, when you compare with the triangles, I think circles are much easier. But then again, it depends on the question. So it's the best thing is you should not decide what you should choose by now. Be ready for all the 12 questions. In the exam, if you feel it difficult, whatever the question, you can drop. Don't decide now. Shall I raise? All right. What is the first theorem you learned under circles? What is the first theorem you learned under circle? 360? No. Okay, can you tell me any theorem you know? What are the theorems you know about circles? Area, perimeter. Area, perimeter are not theorems. Yeah, they're geometrical theorems. When what you use in proof questions. Any theorem you know? ABC. Any theorem? Okay, any theorem related? Yeah, we are getting some answers. Tangent theorems, alternate segment, cyclic quadrilateral. All right. How about the first one out of them? Related to chords. You know what is a chord? What is a chord? What is a chord? Yeah, chord. What is a chord? What is a chord? A line joining 2 points of a circle. Okay, so can you tell me the theorem related? Okay. So the first theorem was, if you drop a perpendicular to the chord, to any chord from the center of the circle, perpendicular means it's going to be 90 degrees. So if you drop a perpendicular from the center to the chord, that is going to divide this line into two equal parts. Simple, right? So that is going to divide this line into two equal parts. Again, if you have a chord, you have the center, you drop a perpendicular from the center to the chord, that is going to divide the chord into two paths. And then the other theory is the other way of that one, which is you have the center of the circle and you are going to draw a line to the center of the chord. And that is going to make 90 degrees here. So those are the first two theories. Can you remember them? Just think like if you take a circle, you have a chord. Do you think these two are equal? Why? They are the radius, right? So these two are equal. So if you just, without changing, if you just make them smaller, what is the shortest distance you will get to the chord? That is going to be this perpendicular distance. That is going to be the shortest distance from the center to the chord. That is why we are telling this is going to be 90 degrees. They will come towards each other and meet at the center, right? So this is the first theorem. We are not going to write any notes, but let's draw them. You all are from one school or different schools? I didn't get the last part, which you was drawing in blue. No, this is just to explain. I mean, it's not a theorem. I was just telling these two are equal, right? So the shortest distance, I mean, if you just bring these two lines towards the center, they will meet at the center. So they will come towards the center and it is going to be the shortest distance. It's going to be 90 degrees. This is not a theorem. I just told you. Remember, I mean, easy way to remember. Just coming and this meeting at the center. All right, if you're done, let's do question number 3. Question number 3 in the tute. Okay, Sahana. Something like this. I mean, this theory is like you have the chord, you have the center, right? So if you draw a line from the center to the center of the chord, I mean, drop a perpendicular that is 90 degrees, it is going to divide this into two parts. That means if the length of this chord, let's say it is 10 centimeters, and you drop a perpendicular to the chord. So this length is going to be 5 centimeters. This length is going to be 5 centimeters. That is the basic theory. Is that clear? Yes, Fatima, yeah. Okay, then let's do question number 3. Question number 3. Question number 3. The radius of the circle is, in the circle with center O, AB and CD are equal chords. Prove that OP is equal to OQ. Simple. Done? Finish? If we get proving questions in part 1A, do we need to write the theorem fully? No, not important. And they are not asking proving questions in part A. Only they will ask the theorem, maybe they ask, but they will not ask proving questions directly. But as a practice, every time, write whatever you know. Don't be lazy, write everything. All right, what do we have? Are you done? Are you done? Are you done? Are you done? Yes. Okay, so here we need to show that OP and OQ are equal in length. How can you do that? How to do that? How did you do it? How did you do that? By the pencil, okay. Let me say what you wrote with the pencil. Yeah. Okay. Okay. So you can just draw two triangles, right? So in this triangle, what can you say? In this triangle, what can you say? This is equal to this, right? Okay, congruent. So when you're proving that something is congruent, there should be 5 steps. First one is write the two triangles that you're considering. What are the two triangles? Okay, why congruency? Because I am going to show that these two triangles are congruent, and then I'm going to show that because they are congruent, these lengths are equal. Is there any other method that I can use? Right? If there is, you can use. So considering two triangles, AOP triangle and what is the other triangle? COQ triangle, right? You can write in. So now you need to write 3 things because congruency means we have how many cases? What are the cases? SSS case, side, 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 angle, side, and right angle, hypotenuse case. Okay, so here you can see a right angle, right? What is that? OPA is equal to OQD, right? OQC is equal to 90 degrees. What else? What are the other things you can see? Radius. That is AO is equal to OC, right? You can see AO is equal to OC. Why is that? Because they are the radius of the circle. And anything else? AP equals CQ. Okay. Why? Why? Huh? Chords of a circle. Yeah. But how you know that AP is equal to CQ? Yeah. So, okay. In the question, it is given OP is equal to OQ, right? So, in the question, it is given what? OP is equal to OQ. Why don't you use that one? Oh, that is what we need to show, right? Sorry. Yeah. ABCD are equal chords. Sorry, yeah. It is given AB and CD are equal chords. So we know this thing. AB and CD are equal chords. That is the thing given. So now what? How can we use this one to show that AP is equal to CQ? Yeah. So you know, if you divide by 2, that means since this is a perpendicular drawn, this is a perpendicular, right? So you know, when you drop a perpendicular, this is going to split into 2. So here, this is half of AP is half of AB, right? And CQ is half of CD. So if AB and CD are equal, half of them are also equal. So because of that, you can say what? AP is equal to CQ. That is first one, this is second one, this is third one. So therefore, you can say AOP triangle is congruent to COQ triangle. And what is the case? SAS, is it? Yeah, it's right angle. SAS case. So because they are congruent, what can you tell? Because they are congruent, you can say this is equal to this. Why is that? Corresponding sides of congruent triangles. You have to write the reason. Corresponding sides of congruent triangles. Elements are equal, yeah. Can we take same segment? Yeah, you can also take, but still we did not. Do we have same segment? Pythagoras theorem. How can we use Pythagoras theorem? Yeah, you can use Pythagoras. Yes. You can use that to prove. Okay, understood? All right, let's do question number 4 also. Tell me the answer. Question number 4. Okay, how AP is equal to CQ? AP is equal to CQ. Again, in the question it is given this AB is equal to CD, right? In the question it is given this one is equal to this one. So according to our theorem, we know from the center, if you drop a perpendicular, this perpendicular is going to divide into 2 parts. You guys can do if you understood. Okay, so this is dividing into 2 parts. So if this is going to be half of AB, this is going to be half of AB. That is, AP is going to be half of AB. Same way, this is going to be half of CD. CQ is going to be half of CD. So if AB and CD are equal, these lengths are obviously going to be same. Hope you got it. Because of this, you can write half of CD is equal to AB, right? So instead of CD, you can write AB, half AB. OA and OC line. It's okay. You can construct from the center to the meeting point. You are just drawing the line to complete the triangle. It's not a problem. Yeah. Put on. 12 centimeters, 13 centimeters. How did you get 5? Method එක නම් clear නෑ. Thinking. Which question? Question number 4. In SA's case here, the 90 degrees is not the included angle, is it? We showed that this one is equal to this one, and this one is equal to this one, and this is the included angle, right? It is the included angle. Finish. I'm sorry, 20. Let me see the working. Let me see. How you know? Uh-huh. Oh. Huh? How much? 34 centimeters. Okay, let's see. Okay, so we have a circle. What do we have? The radius of the circle is 13. We have P, M, O, T, N, S, Q, R. Okay, the radius of the circle is 13 centimeters. Okay. If PQ is equal to 24 centimeters, this is PQ is 24 centimeters and TQ is equal to 7 centimeters. The small part is 7 centimeters. Find the perimeter of OMTN. OMTN. Okay. So how to do that? I'm sorry? OM is perpendicular line drawn to, yes, that is correct. So we have OM, this is a perpendicular drawn to PQ. PQ is a chord. So what does that mean? This length is 12 centimeters, right? This, I mean, PM and MQ are going to be equal. This is going to be the midpoint. So that means this is 12 centimeters and MQ is going to be 12 centimeters. So if MQ is 12 centimeters, then TQ is 7 centimeters. How much is MT? 5 centimeters, right? MT is 5 centimeters, right? This is 12, this is 12. So, but even though this is 12, this is 7, that means this is going to be 5. This is a square they have told. So what is the perimeter? 20. But you didn't have the method. Okay. But in the paper, the method is also required. Okay, so how do you write it? you can write M is the midpoint of chord. What is that? PQ, right? Chord PQ. You can write the reason within brackets, and then therefore, what is that? MQ is equal to 12 centimeters. Therefore, MT is equal to 12 centimeters minus 5 centimeters, there, which is equal to 7 centimeters, which is equal to 5 centimeters. Therefore, perimeter is equal to 5 times 4, which is 20 centimeters. All right, so next part, angles in a circle. The second part, right? Angles in a circle. They have given the radius as 13. No, yeah, there is something extra, right? Yep. So there is not use. How did you get 4? How did you get 4? Where's 4? Oh, the 4, because you have 4 sides. I mean, what is the perimeter? 5 plus 5 plus 5 plus 5. They are asking the perimeter of this square. So 5 plus 5 plus 5 plus 5. That is why 5 times 4. This question number is question number 4, Zainab. Okay, I will erase, right? Okay, angles in a circle. So when talking about angles in a circle, again, there's something important. So if you draw a chord, this will divide the circle, the circular part, into 2 parts. What are they? This is called the minor arc and the major arc. These are 2 arcs. So here we have the minor arc, and here we have the major arc. This is the major arc. So when talking about, just imagine someone is standing on this, something like keeping 2 legs. So we call this, what do we call this? Angle. What do you call this angle? Here we have an arc. So just forget about this chord, okay? So here we have an arc. So this guy is standing on that arc and his head is on the circle. So what do we call this angle? Yes, angle subtended on the remaining part. We are talking about the small circle, small arc. So we call them the angle subtended on the remaining part of the circle. How about this? How about this? Yes, double. Yes, that is correct. But what do we call this angle? Triangle? Angle. What do you call this angle? Yes, angle subtended at the center of the circle. Where is the head? At the center. So we call it angle subtended at the center of the circle. Here, where is the head? on the other part of the circle. So we call it angle subtended at the remaining part of the circle. Okay. So what is the theory? What is the theorem related to these two things? Yes. So if this one is x, this is going to be 2x, simple. If this one is x, that is going to be 2x. That is the theory. Any questions on that? Let's write it simple. So here also we have the other one also. Look at this. If you have something like this, what is this? Now the guy is standing on the not in the smaller arc, but in the not in the smaller arc, but in the on the larger arc. So in that case, this what you call angle subtended at the center is on the other side. Here you can see both are in the same way, right? But here they are in the opposite way. In this case, just keep in mind, if you have this angle, this is the other angle which is corresponding to that. Always remember they are in the same way, right? As a shortcut method, here you can see this is like this and this is also like this, right? So here also it's same. If this is the angle you are considering, the other angle is this big angle, but in the same way, right? So if this one is x, this angle is going to be 2x, not this angle. Keep that in mind. Okay, never take this angle, because if you take this angle, how will it be? It will be in opposite directions, right? So yeah, write it down. These are the same theorem, but in two different ways. Right. This is the under okay. Right. Next one. What is the next theorem? After this one, what is the theorem that comes with this one? Same way of deriving. If you have a circle, right, you have a chord. Now, if this one is 2x, or let's say if this one is 2x, what is this angle? X. If I draw another triangle, what is this? X. If I draw another one, what is this? X. All of them will be x. So this will give us our next theorem. What is it? Angles in the we said that if you draw a chord, it will divide the circle into two segments, the major segment and the minor segment. So angles in the same segment are always equal. We call them angles in the same segment, right? The reason is it is coming from the first theorem only. So always, if you see in the same segment angles, that means head is on the circle only. So then all these angles are equal. That means if this one is 10 degrees, all of them are going to be 10. That is the next theorem. Simple. So up to now, how many theorems? 4, 3, 3, right? The chord one, this one, and this one. Right. This is the second one. Angles in the same segment are equal. So this is also valid to the minor segment. That means if you have a circle, if you have a chord, angles in the minor segment are also always equal. These all are equal. Okay, next one. Angles in a semicircle. This is the third one. What is the angle in a semicircle? Half circle, all right. So half circle means half circle. So, okay. What the? Right. Tell me. Huh? Tell me. What is it? What is the theorem? Yes, it is equal to 90 degrees, right? Why is that? Again, our theorem. Again, we can use our theorem. What is that? We have the first theorem, right? If you have a chord, something like this is tx, 2x, and this is x. So if this is twice, this is going to be half of that one. So according to this one, what is this angle? 180. So this is going to be half of that one, which is 90, right? So again, this theorem is coming from the first theorem. All these angles, whatever the angle, if it is the diameter, if it is coming from a diameter, it is going to be 90 degrees. So in many questions, you get, in the exam, they ask to prove that. They just give a line in the diagram. There will be, let's say, AB. They give the question, show that AB is a diameter. In that case, what you have to do is you have to show some such thing is equal to 90 degrees. If you can do that, you're done, right? Yes, that will be possible. Upul. Okay, so that is the third theorem. Angle in a semicircle are always 90 degrees. If AB is a diameter, the angle subtended is always 90 degrees. Simple. Again. So these are everything you learned in grade 9. Did you? 10. In grade 10. All these theorems are from grade 10. So here we have three theorems and we have the chord theorem. Right, shall I erase? Right? Okay, next one is cyclic quadrilaterals. Here we come to grade 11. Cyclic quadrilaterals. What are cyclic quadrilaterals? Number 4, right? Whatever. Cyclic what are cyclic quadrilaterals? Okay, that is a theorem. I mean, what is a cyclic quadrilateral? Yeah, exactly. So, cyclic quadrilateral is something. What is a quadrilateral? You have 4 sides, right? In a cyclic quadrilateral, all the 4 vertices lie on the circumference of the circle. If it is like that, it is called a cyclic quadrilateral. So, related to cyclic quadrilaterals, how many theorems do we have? 3, 4. What are they? Okay. Okay. And what is the third one? What is your name? Yeah. Abdul Malik. Okay. Tell me. What is the third one? Fourth one? Third one? Basically, yeah, we can say 2 theorems. No need to collect, right? We can say 2 theorems. What are they? First one is like the opposite angles are supplementary. What is supplementary? Equals to 180. So when you add these two, it is always going to give you 180. If it is a cyclic quadrilateral, it is always going to give you 180. So basically, there are 2 theorems in your book. Based on this one, they have given 2 theorems. What are they? The first one is, if it is a cyclic quadrilateral, when you add them, it will be 180. The other one is, in any quadrilateral, if you just add them, if you get 180, then it is a cyclic quadrilateral. Something like that. That means, in a cyclic quadrilateral, if you add the opposite angles, it will be 180. In any quadrilateral, if you add and see whether it is 180, and if you get the answer as 180, then it is a cyclic quadrilateral. These are the 2 theorems. No need to remember them as 2. Just think, just in a cyclic quadrilateral, it is 180. If someone asks you, show that this is a, if someone asks you, show that this is a cyclic quadrilateral. How to show that? We need to find this angle somehow, and we have to show that when you add these two, you get 180. That's it, right? The other theorem is also coming from the same theorem, right? The third theorem. What is that? Yes. So that theorem is, let's say this one is x. If this one is x, what is this angle? 2x. I just told that when you add these 2 angles, they are going to be 180. So let's write like, I'll just name A, B, C, D, and E, right? So you want to find this ADC, right? So let's write ADC plus x is equal to 180, isn't it? Why is that? Because they are supplementary. ADC is this angle, this is x. When you add them, you get 180. So you take this x to the other side. How can you take this x to the other side? You subtract x from both the sides. Then you get 180 minus x. So this is 180 minus x. If this is 180 minus x, this is going to be how much? Yes, right? Why is that? This is a straight line. In a straight line, straight angles are what? Equals to 180. So there you can write what? This angle is 180 minus x plus this angle is CDE, right? CDE is equal to what? 180. So now you bring all of them to the other side. That means you have to subtract 180 and you have to add x. So you have to do the same thing to the other side. So you get what? CDE is equal to 180 minus 180 plus x, which is equal to x. So that is why we get x here, right? Nothing, you don't have to do this much calculation, or always if you get, if they are supplementary, that means if this one is x, the other one is going to be 180 minus x, definitely, every time. So if this one is 180 minus x, the other angle is going to be x, because when you add them, it is going to be one. Also in complementary, if this one is x, this is going to be how much? 90 minus x, right? No need to do this much calculations, you can simply get it. So if this one is x, this is going to be 180 minus x. If this one is 180 minus x, this is going to be 1x, because when you add them, it goes up to 180. So that's why we say exterior angle is equal to interior opposite angle. So this is the interior opposite angle. All right. Let's write the three things. This one. The three theorems. Explain the first theorem. First theorem is nothing, like simply in a cyclic quadrilateral, if you add these two angles, it is going to be 180. That means if this one is A, if this one is B, A plus B is equal to 180. Right? So far, I'll let you know. Okay, next one, two more theorems. That's all about circles. The last two theorems, what are they? Related to tangents. Right, what is a tangent? A line Right. If you get a circle, is this a tangent? We call it a, okay. If these two parts are not there, we call it a chord. When you extend it, we call it a secant, but it's not in your syllabus. Anyways, keep it like this is a chord. But this chord, when you just bring it down, 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 there's going to be one place where it touches the circle at one point. That line, we call it a tangent. Right. So this is called this is a tangent. It's just touching at one point. There are no 2 points. Okay. So the first theorem on tangents, what is that? What is the first theorem? That is going to be perpendicular, right? So that means, why is that? Look, what is this? Right. We have 2 lines, right? These are going to be equal. Listen, right? These are going to be equal. So this is an isosceles triangle, isn't it? So then these 2 angles are also equal, right? Now I bring this line a little bit down, right? They are not parallel. I mean the same line, I bring just a little bit down. Then what happened? What happened to the angle? What happened to the angle? Yeah, same. And what about the size of the angle? What do you think? It increases, right? And if you take more down, what happened? It increases. So there's going to be one point where both these lines overlap with each other. So it comes like this, like this, like this, and it overlaps at one point. At this point, it overlaps. So that means, that is why we always say the line, when you overlap, the full angle, what is the full angle? 180. So since these 2 angles are equal, right? Every time these 2 angles are equal. So at this point, it is going to be 90 because they are equal, right? So if you, for a tangent, if you draw a line from the center that is radius to that point, that line is always going to be 90 degrees. That is the next theorem. So let's write tangents. Okay, short and sweet. Short and sweet is like, from there is a tangent to any tangent. If you draw a line to that tangent from the center, that is, if you draw a radius, that is going to be 90 degrees. Simple. That's it. That is a short and sweet thing. Okay. Okay. All right. The next theorem. This is the first theorem on the tangent. And the next one is, again, in the book, it is given a little bit complicated way, but it is not that complicated. But you have an external point. Okay. So from this external point, you are drawing 2 tangents. If you draw 2 tangents, you have the center. Then we have this radius. And this radius is going to be 90 degrees. Why is that? Because of our previous theorem. Now I will draw another line that is connecting this, right? So now what can you tell about these two triangles? Equals. What do you mean by triangles are equal? Triangles are congruent. Yeah. So we have a common side, we have a 90-degree angle, and what else? We have the radius. So because of those three things, we can say what? These two triangles are congruent. So if these two triangles are congruent, there are a lot of things that will happen. What is that? What are they? First one, these two angles are equal. This angle is equal to this angle. What else? This length is equal to this length. Anything else? Nothing, right? Both triangles are congruent. So all these three things you have to remember. Now, I mean, no need to remember, right? Just remember, just keep in mind these two are congruent. Explain again. Okay. Yeah. So the theory is like you have the external point. From an external point, you are drawing two tangents. All right. So when you draw two tangents, this angle is 90 degrees, right? So here, when you consider, let's name them O, A, B, C. Okay. So in the AOB triangle and COB triangle, what can you see? I mean, if you remove these blue color things, alphabet. I mean, geometrically, what can you say? What can you see? I mean, just think, look at these two triangles and see what are equal. What are the equal things you can say? I mean, you need to show that these two are congruent, right? So to say that congruent, you need three things. So, OA equal to OA equal to OC. Why is that? Radius. All right. Next one. AB equal to CB. No, we do not know that. AB equal to CB. We do not know that. OAB is equal to OCB. That is an angle, right? OAB is equal to OCB. Reason? The previous theorem you have to write, right? Because the radius is perpendicular to the tangent. You have to write that. And the last one is, for both these triangles, we have a common side. So you can say OB is common. So because of this reason, what can you say? The two triangles, these two triangles, AOB is congruent to COB triangle. So if they are congruent, so these two triangles are congruent, there are a lot of things. I mean, the corresponding sides. Here we have shown only three things. I mean, congruency means what? In any triangle, if you consider a triangle, there are 6 features. What are the 6 features? The 3 angles and 3 sides, right? 3 angles and the 3 sides. So for congruency, to show that 2 triangles are congruent, we are taking 3 such features, and we are only, I mean, if 2 triangles are congruent, all these 6 features are going to be equal in these 2 triangles. But just to say that, to show that 2 triangles are congruent, we are using 3 features. But we have 4 special cases. We have to show that 3 sides are equal, or 2 angles and 1 side, or 2 sides and 1 included angle. So likewise, we have 4 special cases, right? So here we have used 3 features and shown that these 2 triangles are congruent. So since these 2 triangles are congruent, the remaining 3 features are going to be equal, right? So what are the remaining 3 features? Yeah, we have this side. We did not use this side here. That means we can say this side is equal to this side. Then this angle is equal to this angle, and this angle is equal to this angle. These things you can always use as a theorem. You can directly, I mean, you don't need to show that. I mean, if they ask, in a question, you can always say these two angles are equal hereafter, because now we have already learned this as a theorem. You don't have to prove that these two triangles are congruent. That's it. So yeah, got it? No, as only in Candy. Right? Last one. What is the last theorem? What is the last theorem? Huh? What? What is the last theorem? Right. Okay, so for this one, we need to understand what is alternate segment. All right, so now, again, you know what is a segment, right? Listen. Segment means we have two segments here. This is the major segment, this is the minor segment, right? So now, from one of these places, we are going to draw a tangent. So there is an angle between this tangent and the chord, right? So what is the alternate segment? The segment on the other side of the chord, all right? So here we have one chord, here on the other side we have another chord. So this is the, not the chord, segment. So this is the alternate segment. So then again, if I have something else, let's say, we have so if I consider this angle, what is the alternate one? The smaller one or the larger one? Larger one? Smaller one, right? This is the angle in the other side, in the opposite side, this is the segment. This is the alternate segment, right? Here also we consider this angle, this is the alternate segment, right? So here, the theory, what is the theorem? There is a proof for this theorem, but in your syllabus, this proof is not there. So no need to talk about that, just keep in mind. So if this one is x, the angle in the opposite segment is going to be x. The angle in the opposite segment is going to be x, right? This is the theorem, simple. Here also same thing. If this is y, the angles in the opposite segment are going to be y. That's it, right? How many, I mean, there's going to be a lot of any angle. We know all these are equal, right? This is a chord. We know these angles are anyways equal. So whatever the angle, this is, if it is, if you see a tangent and a chord, that means this is the angle in the opposite segment are these angles. They are going to be equal. Okay? Akkala. Right? No. Right. Okay. Did you understand this? Okay. Hold on, Safa. You can. Harne, right? Okay, so right, first one, what is the first theorem? Chord. That is going to be, the line drawn is going to be 90 degrees. Simple. Second one, angle subtended at the center is going to be twice. If this one is 2x, this is x. Next one, angle in a semicircle, they are 90 degrees. Next one, cyclic quadrilateral. Yeah, cyclic, in a cyclic quadrilateral, angles are what? Supplementary. Yeah, 180. And the next one is exterior angle is equal to interior opposite angle. And the next one is tangent. In a tangent, it is 90 degrees. The next one, if you draw from an external point, these two triangles are congruent. These two triangles are going to be congruent. And the last one is, what is the last one? Alternate segment. That is, this is going to be equal to this. If this one is x, these are going to be x. So these are all the theorems you learned in grade 10 and 11. So if you just, if you know these theorems, definitely question number, I cannot remember, maybe 10, I think, 10 or 11 in your exam. So that question, the circles question, definitely you can do. Just you need a little bit knowledge about what triangles also, but this geometry one is going to be really easy. If you know these, how many are there? 1, 2, 3, 6, 8, 8 or 9 theorems, right? So these are simple 8 theorems. Shall we try to do question number? Break? Just 2 hour, 2.5 hour class. Why you need break? 3 hours nang kamak ne. 2.5 hours, half hour break. Okay. At the end, I'll give you half hour break. It's okay. It's an easy room. So let's do a past paper question. Question number 22. Let's do question number 22. Also, in the first part, there is going to be 4 or 5 questions. Nothing. Right? Yeah, like sir. Can you send? Yeah. If you want You can send me a message afterwards. I'll share. Okay, question number 22. So these questions, as I told you, have 15 minutes. Let's do in 10 minutes. 10 minutes. 2014, yeah. Question number 22. Asma, yeah, sure. It is a summary. So this is like a brief summary of everything. Kan. Try. So how many of you are planning to do maths for A-levels? Maths for A-level. Double maths. London or local? Oh, okay. Okay, we have online students. One, two, three, 4, 5, 6, 7. Washroom? Urgent? Okay. No, only one is enough, right? No, he was kidding. Right. The point ABC lie on the circle shown in the figure, and PQ is a tangent drawn to the circle. Copy the figure, draw perpendicular to PQ and from C, and mark its foot as D. That is easy, right? And draw the perpendicular to BC from A and mark its foot as E. Let's do. Draw a perpendicular to PQ from C. So according to my diagram, it is impossible to draw. You need to draw a perpendicular to PQ, something like this. PQ, right? Perpendicular from C to PQ. And then, and mark its foot as D. Mark its foot as D. And draw a perpendicular to BC from A. From A, you need to draw a perpendicular. This diagram is a little bit, I'll just draw again. So you need to draw a perpendicular to BC from A. BC from A. That's it, right? Give reasons as to why AECD is a cyclic quadrilateral. AECD. Where is AECD? Picture is not clear. AECD. Where is AECD? Where is AECD? This is D, right? So they are asking why this is a cyclic quadrilateral. You can see here, right? This angle is 90 degrees. This angle is 90 degrees. So this is a quadrilateral, and in the quadrilateral, the opposite angles are 90 degrees because the opposite angles are supplementary. You can tell it is a cyclic quadrilateral. Did you get it? Okay. Diagram clear then? As he told. Right, Mehmedi, it's like this, right? We have P, A, Q here, and we have B, C here. They're asking us to drop a perpendicular from here to here, and another perpendicular from here to here, right? So now they ask and mark this as D and mark this as E. So now they're asking us the reason why AECD. AECD. Where's AECD? A, E, C, D. This is a quadrilateral, isn't it? Okay, they are asking why this one is a cyclic quadrilateral. So according to our theorem, I told you in any quadrilateral, when you add the two sides, if it is 90 degrees, if it is 180 degrees, we can directly tell that they are cyclic quadrilateral, right? So here also you can see this is 90 degrees, isn't it? This is 90 degrees, isn't it? So when you add the two sides, two angles, you get 180. So directly you can tell it is ADC plus AEC is equal to 90 degrees plus 90 degrees, which is equal to 180. Therefore, you can write AECD is a cyclic quadrilateral. That's it. Sinet, it is question number 22. Part 3. It's 180. Can you explain the reason? The reason is the opposite angles are supplementary. Whenever you get a question to show that a quadrilateral is cyclic quadrilateral, always try to show that opposite angles are supplementary. That means when you add two opposite angles, you get 180 as the answer. Always do that. That's it. Okay, next question. Taking PAB is equal to X. PAB is equal to X. Where is PAB? PAB as X. And giving reasons, each of AC, what is it? Find giving reasons, you find what? We need to find ACB and ADE. Where is ACB? ACB, this one. And ADE. ADE, this angle. Okay. How to find? Did you find? Okay, tell me, how do you find? What is ACB? X, right? Why is that? Right, we just learned the theory, right? Here you can see this is a tangent. This is a chord. So here, this is the angle between the chord and the tangent. So there is this angle is coming from that same chord, right? From the same chord only, that angle is coming. So this is the angle in the alternate segment. So definitely you can say what? Directly you can tell ACB is equal to X. The reason you have to write angles in the alternate segment. Angle in the alternate segment. And how about ADE? Where is ADE? ADE. This one. How do you find that one? 90 minus X. How did you get 90 minus X? Yeah. This is X, okay. And what can you tell using English letters? How about others? Find ADE. Yeah. Your answer is, maybe it is correct, but I'm just asking, how did you get? Okay. Right. Feedback. Tell me, how can we do this? Angles on the same segment. Okay. So here, now when you see this, when you see such things, like you need to find ADE, right? Where is ADE? This angle. So what with what you can get a relationship? Just look at this. What is that? Is it a chord? No, it is not a chord. Then which one you can get? No idea. Okay. So here, look at this one. Are there any other chords coming out of this one? No. Then this one is X and this one is 90. How about this one? 90 minus X. What else you can say? Just think, anything, whatever you see. Any other guesses? Any other things that we can find? Okay, if this one is 90 minus X, what about this one? What about this one? Huh? What about this angle? This full angle? Is the diagram okay? No, it's not 90. This is 90 minus X. Okay. එක තමයි ප්‍රශ්නේ නේ. අපි ඒක පොඩ්ඩක් ලස්සනට අඳිමුද? මොකද? ඒක දැන් මේ ඩයග්‍රෑම් එක ඇඳ 10 පාරක් විතර. Okay, this is a circle and here right. Now what do we know? This is E. What do we know? අපි මොනවද දන්නේ? X. Which one is X? This one is X, right? This one is X. If this one is X, angles in the alternate segment, we know this is X. Okay, not a problem. So now we need to find A, D, E, that is coming from here, right? This angle. Right. Then Kiyamba, how to do that? Tell me. Any idea? Can taga. Online students. Yanu. If this one is a 90, okay, and then I'm sorry, yeah, that, but the problem is this one is x, this one is this one, this is this one x, is that x? So we cannot directly tell, right? Is that x? No. Why is that? Then what can we take? Go ahead, 90 minus x. Go ahead, go ahead. Huh? This one is 90 minus x. It was it. What else? What else? Anything else you can use? Yeah, online students? SPAB. Are these two angles equal? Are these two angles equal? Why? Is it given? No. But we have shown AECD is a cyclic quadrilateral. AECD is a cyclic quadrilateral, right? So if it is a cyclic quadrilateral, what can you say? Equals to 180. And so this is a, yeah, this is a cyclic quadrilateral, right? Look, this is a cyclic quadrilateral. So in this cyclic quadrilateral, this side is extended, is it? Yeah. And if this is extended, this angle is how much? Oh, sorry, this angle is 90, this angle is 90. This angle, how much is this angle? How about this angle? 90 minus? How about this full angle? 180 is this angle plus this full angle is 180. Then, but we need to find this angle. How to do that? Huh? What? You should draw. Tell me how to do that. Online students, angles in the think. Kita ba? Kita ba? Hitan, I'll give you 3 minutes. 3 minutes to think. Now we have done 2 parts. So third part, I'll give 3 minutes to think. No. Right. Look. Now, doubt. And ulong idan. Huh? Bisect in AD, no, AD is not equal to 45. How about? Right. Yonder. Now, okay. No idea? No idea? How about you? No idea? Right. Now look, we have shown that ADCE is a cyclic quadrilateral. What does that mean? There is a circle passing through this thing, right? So if there is a circle, so just think, there is a circle passing through I'm drawing this ADEC quadrilateral, right? This is ADEC, this quadrilateral. We have already shown that this is a cyclic quadrilateral. So here we have this AC side, right? So this is, and this angle, how much is it? 90 degrees. So AC is definitely a diameter, right? And how about AE? It is a chord, right? AE is a chord. And what is this angle? X. This angle is X. So here from AE chord, we are getting this one. AE is a chord, not for this circle, but for another circle that we do not have here. But we have already shown that ADCE is a cyclic quadrilateral, right? So this is a chord. So the chord is coming like this. And you can see this one is also coming from the same chord. Did you see that? That means, where is that? We have this, something like this. This one and this one coming from the same chord. So this angle is also going to be X, isn't it? Got it? Again, in the second part, listen, in the second part, we have shown ADCE is a cyclic quadrilateral. A cyclic quadrilateral means there is a circle passing at the vertices, through the vertices of that quadrilateral. So here, there is a circle that is going through AECD, right? So if there is a circle going through, that's this A and E lies on that circle like this, right? So from that one, we are getting this angle, which is X. This is X. So same angle is coming from the other side. This is X. Angles in the same segment. Because of angles in the same segment, ADE is equal to X. Got it? Right. Online students? Show that the lines AB and DE are parallel. AB and DE are parallel. Nothing. Can you show that? Can you show that AB and DE are parallel? AB and DE are parallel. We have to show that AB and DE are parallel. How to show that? How? Reason. Okay. ADE is also X. So they are parallel, correct. Right? So you can see, we already show that this angle is X. So this angle is equal to this angle. So simply you have a line. This one is X. This one is X. So if both these angles are X, we have corresponding angles are equal. So if corresponding angles are equal, you can directly tell they are parallel. Last one. Give reason as to why the center of the circle passes through the points E, C, and D should lie on AC. Again, simple. I already told the answer for that. For the last part, I already told the answer. Pavitran. EAC is equal to EDC. EAC is equal to EDC. Yes, Pavitran, you can do that. You can tell that. That is correct. Antimega, last one. How is it? Last one. Last one is, what are they asking to say? Show. Give reasons as to why the center of the circle that passes through the points ECD should lie on AC. That means we have to give reason why the center of the circle that is passing through EC and D. There's a circle that is passing through EC and D. The center of the circle lies on AC. They're asking why. Because AC is a diameter. How do you know AC is a diameter? Did we? I told, yeah, we did not prove. So we have to say because this is 90 degrees, it is the AC is the diameter, because we know angles in a semicircle are 90. So if this one is 90, this is the diameter. If it is a diameter, center lies on AC. You have to write it clearly. Next one, question number break. I'll give a break in 15 minutes. No, after 15 minutes. Okay, question number 38. Question number 38. Oh, 24. Let's first try 38. Okay, Shama? Question number 38. First part, ACB is equal to 45 degrees. Can you show that? Right, look. In the given figure, the tangent drawn to the circle at with center O at A. We have this point A is XAY. XAY. The chord AB bisects XAO. Where is XAO? We have here XAO. So the chord AD bisects the chord AB bisects XAO. That means we have a chord AB and it will bisect these two, the full angle. This angle they are going to bisect. The diameter AD has been produced to E. The diameter AD has been produced to E. Has been produced to E. And the point C lies on the circle between the points B and D. So we have B here. There's another point C. Now, moreover, the point of intersection of AC and OB is P. Okay, so now we have AB and AC and OB. Right, this is the diagram, right? Now the first question is, show that ACB is equal to 45 degrees. How to show that? ACB is equal to 45 degrees. Bisector, okay. So before showing that it's a bisector, okay, it's a bisector. Yeah. First of all, we have to tell what? ABC equal to 90. Why? Why ABC is equal to 90? AC is not the diameter, right? AD is the diameter. How can we show that ACB? Where is ACB? ACB. We need to show that this is 45. How to show that this is 45? BCD is 90. Why? BCD, this one is 90. Why is that? Where is it given? No, it is not BCD, it is ACD is 90. That is anyways 90, right? Because AD is the diameter, so this angle is anyways 90. Yeah. Yeah. But this is not a cyclic quadrilateral. Is it given?
No.
Mm-hmm. Yeah. Which one? Mm-hmm. But here in this question, we already show that. Give reasons as to why AECD is a cyclic quadrilateral. We already show that AECD is a cyclic quadrilateral. Yeah. Yeah. Here, right? Here, we all AEC, where's D? Where's D? Here, right? Okay, something here. So here we already showed that this is a cyclic quadrilateral. That means there is another circle that is passing through these 4 points. Because we already show that this because of this question, right? We already said that it is a cyclic quadrilateral. Not that circle given, it's another circle. All right, so here, what can you tell? Just look, this is the center, it is coming to this point, this is a tangent. So what is this angle? 90 degrees. So if this angle is 90, this angle is also 90. So this AB is bisecting the angle. So what is this angle? 45 degrees. So what is this angle? 45 degrees. All right. Now can you tell what is BCD? BCA. We need to find BC, ACB. ACB. Now can you tell me? 45. Why is that? Reason. Opposite angle in the alternate segment. Look at this. This is a chord. This is a tangent. Angle between the chord and the tangent is 45. Then this angle is right over here. Angle in the alternate segment, 45. Got it? Same thing. Something like this. We have a tangent. We have a chord AB. We have something like this. This is ACB. Right? So these angles are equal. If this one is X, this is X. That's it. Angle in the alternate segment. Right? So if this one is 45, this is simply 45. How do we write the answer? In proof questions, it is very important to write the reason. So how do you write? First of all, you need to tell that this is 90 degrees. So XAO is equal to 90 degrees. What is the reason? What is the reason? The radius, simply write something, right? Radius is perpendicular to the, what you call, tangent at the, right. Next one, XAO. Therefore, what? XAB is equal to what? 45 degrees. Then you can write, therefore, if this one is 45, BCA is equal to 45 degrees. BCA is equal to 45 degrees. The reason is important. You get marks for the reason only. What is the reason? Angle in the alternate segment. No. This one is anyways 90. Why is that? I didn't get it. Yeah. Oh, yeah, that is correct. Correct. That is also correct. Yeah. Here we have a chord. So we have this angle. This angle is 90. So if that angle is 90, we can get this as 45. That is also correct. All right, good. Next one. YAC is equal to CDE. Second part. Just look and try to do that. YAC is equal to CDE. How can we show that? YAC, where is YAC? This full angle. YAC equal to CDE. CDE, this angle. Let's think. YAC equal to CDE. What? Do. Think. Just only the theorems we learned. By using the theorems we learned, we can do this. How to show that YAC equal to CDE? How to show that these two are equal? Right, let's see. Tell me, ADCB is a cyclic quadrilateral, right? So if ADCB is a cyclic quadrilateral, this is equal to what? If this one is X, just let's say this one is X. This one is equal to what? ACD is 90, yes, that is correct. This one is 130, okay. This full angle is 135, okay. Yeah, and then? Yeah, anyways, it is a cyclic quadrilateral. Yeah. Right, just tell me, answer my question. What is equal? Can you tell me another angle which, because we have to show that YAC equal to CDE. I don't know what to do, right? So what I do is I just select one angle. So I just marked it as CDE. Okay. So then can you just tell me any angle which is equal to this one? B angle, that is ABC angle, right? This angle, that's the red, right? This angle, right? If this one is X, this one is X. Why is that? This is a cyclic quadrilateral. This is the exterior angle. This is the interior opposite angle. So these are equal. All right. So should I write it or no need? Let's just mark, right? And then, can you get a relation between this and this? Can you get a relation between this and this? alternate segment, right? This is a tangent, this is a chord, the angle is there, this is the angle in the alternate segment. So if this one is x, how much is this one? X. So this one is x, this one is x, this one is x, then obviously these two are equal, right? So simply you can write what? CDE is equal to what? OBC. Reason is you can write the reason. Then also you can write YAC is equal to OBC. The reason you can write YAC is this one. YAC? Yeah, YAC is this one. And OBC. OBC is it OBC? It's not OBC, ABC. Right? So now this guy is equal to this guy, this guy is equal to this guy. That means these two are equal. Right? Therefore, CDE equal YAC. That's it. I didn't understand the reason. For which one? What? What? Right. Tell me. The reason. The reasoning. You can see this is x. The exterior angle, if this one is x, this one is x. Then this one is angle in the alternate segment. Because of angle in the alternate segment, these two are equal. Because of cyclic quadrilateral, these two are equal. So obviously everything is going to be equal. All right. So wait. I didn't say. So I need your feedback. Just write whatever you feel. The sections you need to do or whatever you feel. Feedback. And online students, please give me your feedback through a message. What do you need to be done in the upcoming sessions? What you need and what are the sections that need to be covered? And feedback about today's session. What do you think need to be improved? And what do you expect? Was it good? Was it bad? Whatever you feel, just send me as a message your feedback, online students. And next week plan is triangles. So today we did circles. The other geometry part is triangles. So next week the class will be on Saturday 8 a.m. From next week onwards the class will be morning. Yeah, morning Saturday 8 a.m. And this is a free class, right? But from next class onwards you will have to register by paying 1,500. You can visit if online students can go to the website faradayeducation.com and purchase the class. Physical students can register here for the classes. If you have any question, you can ask me. And if you have any questions also, and also about the daily quizzes, if you are in the group, I am sending daily quizzes, just do them and send me. No one is doing this thing, right? I mean, getting your answers corrected and getting a feedback is very important. So just do the daily quizzes and send me. It will take like 15 to 20 minutes. So just do them and send. That will help you, definitely. All right, then. See you next week. How do we join the physical classes? If you want to join the physical classes, you can come to Faraday Institute. Like it's near Trinity College, and you can come and register here. If you're online, you can purchase the course online through the website. All right, then. I think it's the time to say goodbye. See you next week. Bye-bye. Not for you. Sir, emotional damage, sir. Why?